So in this video we will study about the ice chart. So what is the meaning of ice chart? Ice represent I for initial concentration, C for change in concentration, which represent by delta, or E is equilibrium concentration. And how we come? So I, C plus E. Only the equilibrium line can be used in the expression. So we can also understand that if you remember this initial graph, so product is concentration is increasing and reactant concentration is decreasing over the time if there are two concentration, and this region which is called equilibrium region, so this will be I, these will be I, this concentration will be I initial, and this concentration will be C for change, and from E is equilibrium concentration will be these one, right? So let's see one example, then we can understand. I just showed you through the graph. So here is one question that sulfur trioxide decomposes at the high temperature in the sealed container, and initially the vessel is charged by 1000 degree Kelvin. So this is the temperature is given, and the SO3 means reactant concentration was given, initial concentration was 0.5, and at equilibrium the reactant concentration of SO3 is given for partial pressure is 0.2. so since the whole reaction is in the gaseous state, that is why partial pressure is given, and calculate the value of Kp at this temperature. So temperature is not changed, and we have to calculate the Kp value here. And to calculate the Kp value, what we have to do, basically we can use and this is a good example for ice chart. So let me explain how we can write the ice chart for this one. So here 2SO3 gas is decomposing into 2SO2 and plus oxygen. So here you can see this is stoichiometry is 2 mole of SO3, 2 mole of SO2 and 1 mole of oxygen gas, right? 1 mole of oxygen gas is forming. This is the stoichiometry of this reaction. If we will write the I initial concentration, so initial concentration is given for SO3 is 0.5. So here we can write 0.5, and there is no information about the SO2 and oxygen, so 0 concentration, 0 atmosphere. And change in concentration we do not know right now. What they have given, the SO3 equilibrium concentration they have given. So change, you can see, for an example, if we consume 2x amount we consume of SO3, if we consume 2x amount, we will form 2x, because based on the stoichiometry of the reaction, this coefficient 2 and 1. So 2 mole will consume, they will form 2 mole of SO2 and 1 mole of oxygen. Similarly, if I consume 2x mole, I will form 2 plus 2x of SO2 and plus x of oxygen gas. So then what we can do, we can combine these together and find out the equilibrium concentration. So equilibrium concentration will be 0.5 minus 2x, and here 0 plus just forget about these coefficient, they are different, right? 0 plus 2x, so this will be 2x plus and plus x when we add x plus 0. So now, but according to question, you can see the SO at equilibrium, they said at equilibrium the SO3 partial pressure is 0.2. It means the value of this, the value of 0.5 minus 2x they have given you, which is 0.2. They calculate the SO3 of partial pressure, which is 0.2 atmosphere has given, right? So now what we can do from here, we can calculate what is the x value. So we can rearrange this equation. We can write like this one, minus 2x will be equal to 0.2 minus 0.5, and then once we'll subtract this one, it will be minus 2x will be equal to minus 0.3. so can negative cancel out on both sides, so x will become 0.3 divided by 2, and then x value will be 1.5, no, 0.15. So now we calculated the x value because they have given me the equilibrium concentration of SO3, and now we can use this information to calculate Kp. So Kp will be equal to partial pressure of SO2 and partial pressure of oxygen divided by, and then here square will be also be there because of this coefficient, and then partial pressure of SO3. So this will become, we will use these, now we will use these lines, right, in the equation, in this equation. So this will become 2x square, and then for oxygen x square, x only x, and then for SO3 we'll use, it is already given 0.2 in equilibrium concentration, so 0.2 raised power 2, and then what, so we know x value, so 2 multiplied by 0.15 raised power 2, and then x divided by 0.2 raised power x raised power 2. Once we will solve this one, I already have calculated, you can just confirm that if my calculation is correct or not. I got the Kp value from my calculation is this much. So this is the first example of ice table and how we can solve question from ice table. Next I have another example here for ice calculation, which is called example number 2, that 400 at 5000 Kelvin, the reaction of PCl 5 and PCl 3 and Cl2, right, and Kp value is given in the equilibrium mixture at 500 Kelvin. The partial pressure of PCl 5 is 0.860 atmosphere, and partial pressure of PCl 3 is given. So what we have to do here, so you can see, let's solve this question. PCl 5 is decomposing into PCl 3 plus Cl2. So what we can do here, initial concentration is given here, the partial pressure of in an equilibrium mixture. So there is no need to be make ice chart here because everything is given in the equilibrium mixture, in this equilibrium mixture. So this is the difference. If equilibrium concentration is given, then you need not to calculate the, so here you can see initial equilibrium concentration at 500 Kelvin, partial pressure of PCl 3 E at equilibrium is given 0.35 atmosphere, no, 0.35 will be here, 0.35 atmosphere per PCl 3, and PCl5 is 0.8 and 0.86 atmosphere. What will be the partial pressure of this one? And Kp is given, right? So we can easily calculate this one. Kp will be equal to product, means PCl3, and there is no coefficient, so there is all 1, PCl2 divided by P pressure of PCl5. Kp value is given, which is basically we can rearrange this equation first. PCl2 will be equal to Kp multiplied by PCl5. This will go on this side and this will go on this side, divided by PCl3. And now Kp value is, what is Kp value is given? 0.497 multiplied by PCl5 concentration is given 0.860 and divided by 0.35. Now once we solve this question, I will come back that partial pressure of Cl2 will be equal to 1.22 atmosphere. You just calculate and reconfirm if I did correct. So in this equation I did not use the ice chart because they have already given me all the equilibrium concentration. So in the previous question we have to use ice chart because they did not give equilibrium concentration. So these are the two different scenarios, and let's talk to the next, which will be question number 3. And question number 3 is a little different. So question number 3 said that a flask is filled with 1 mole of, oops, my station move. A flask is filled with 1 mole of hydrogen and 1 mole of iodine. So 1 mole and 1 mole. The value of equilibrium constant for their reaction at 448 degrees Celsius is this much. So they have given basically Kp value, or we can say write the Kc value. Kp or Kc is given, basically this whole reaction is in the gas, so we can write Kp. Kp value is given, which is 50.5. What is the equilibrium concentration of hydrogen and iodine and Hi per liter? So I will start like this one. We have to write an ice chart for this reaction, and ice chart would be like this, that initial concentration is given for hydrogen is 1.000 molar, iodine is given 1.000 molar, and 2Hi is given 0, right? Actually they have given in moles, and if you see 1 liter, so basically I will say this is Kc because they are talking about in the molarity form. So Kc value is given, and then change in concentration I will say this is 1 mole and 2 moles, right? So this is my stoichiometry. So if I will consume minus x mole, I will also consume minus x mole, then I will get 2x mole of the Hi. So this is my change. And what will be the equilibrium? We can add these two together to equilibrium. So 1.0 minus x, 1.0 minus x, and then 0 plus 2x will be equal to 2x. So this is the equilibrium concentration. and then now we can write Kc value will be equal to product means Hi raised power 2 divided by hydrogen and iodine. Now we can place all these values. So equilibrium concentration we are going to add, which is I have already calculated and solved this one, so I'm going to narrate this equation from here. So now we can place this value 2x will go into the hydrogen iodide and 1.000 minus x for hydrogen and 1.00 minus x will be for iodine. So we will start from here calculation, and Kc value is already given, so Kc value we can use from here. So what is next? So here you can see these two are the same parameter. Once we will multiply, basically this will become raised power, and if you have raised power on numerator and denominator on both sides, so we can take under root on both sides. Under root means basically we are multiplying the powers, by half, right? So once you will multiply the power by half, they will be cancelled out, and if you will multiply the power, either you can write half or you can take under root. So under root of this one will gone all these power, and then under root of Kc will become 2x divided by this one. Kc value is already given, so we can place the Kc value here, and then once you will take the under root of this one from calculator, you will get 7.11, which is 2x divided by 1.000 minus x. Now we can simplify this to calculate the x value. 7.11 multiplied by 1.000 minus x, and once you will open, it will multiply in both. Once we will open this parenthesis, 7.11 multiply to 1 and 7.11 multiply to x will become this much. Then what? We can move x parameter on same side, so this will become 7.11 equal to 2x plus 7.11x. Then these two will be added together, and then x will become 7.11 divided by 9.11. So from here we got the x value. Now if I got the x value, we can calculate the hydrogen concentration, which is 1.000 minus x, and so basically we have to subtract the x from 1, which will be 0.22 molar, and same concentration will be for iodine, but for hydrogen will be 2x. And if you remember that from where I am talking about these values, basically these values I am talking about from the equilibrium concentration. So at equilibrium concentration, once you know the x value, you can place all these x value to find out the hydrogen concentration, iodine concentration, and 2x for Hi concentration. So this was the third example related to the ice chart, and we'll see two more examples in the next video.